Welcome to part 2 of my Raspberry Pi cluster videos. In this video, we will feature the work needed to get the software up and running to run Einstein Home, a boinc project. If you haven't seen part 1 of this video, please follow the link below to watch the hardware construction. I'm not going to cover how to install Raspbian in this video because if you're at this point, you probably know how to do it. But if in case you don't, visit raspberrypi.org, click on Help, and then under Help, go to Documentation, Installation, and then Installing Images. Here you'll find there are instructions for each operating system of how to install the image to a card once you've downloaded it from the website. To get started, you'll need to download the latest version of Raspbian Jessie. We do that by visiting raspberrypi.org, clicking on Downloads, and going to Raspbian. Here we're going to download Raspbian Jessie Lite. We're doing this because we're running this headless and we don't need a graphical user interface, plus the installation overall is more lightweight. One thing that's a little disappointing is this version of Jessie was supposed to come with a feature that allows one to place a WPA supplicant configuration file in the boot directory and automatically have that copied over to the machine so that you could configure wireless without ever having to attach to the Raspberry Pi. Unfortunately, I've learned that this does not work if you are using the Lite installation, so we're going to have to configure it on the machine the old-fashioned way. At this point, you're more than likely going to have your Raspberry Pi connected to a monitor and keyboard to continue the setup. In this particular instance, I'm going to be demonstrating this through a shell on my Mac because it's a lot easier for me to record the screen capture, but the following is all applicable with a keyboard and monitor at the command line. Now that we have the base installation set up, one of the first things we're going to need to do is configure the Raspberry Pi. We do that by doing a sudo rasbi-config. Now, one of the other new features of Raspbian Jessie with the version we've downloaded is the file system is automatically expanded, so there's no need to do that at this time. However, the first thing we will want to do is change our user password. And we will find that we've changed the password successfully. Next, we go to internationalization options. First, I'm going to change the locale. Now, I'm in the United States, and so I'm going to go down to find the English language, which is denoted by EN. The default comes set up for Great Britain, or GB, so we're going to uncheck that by pressing the spacebar, and I'm going down to EN US and I want UTF-8, and then I'm going to tell it I want the EN US UTF-8 to be the default. Now we're going to go back to internationalization options again, and this time we're going to change the time zone. For me, I'm in the United States and in the Eastern time zone. Now we're going to go to internationalization options for a third time. Only this time we're going to select change Wi-Fi country. And of course, we are in the United States, so we're going to scroll all the way down to US and pick United States. Now, in internationalization options, there is a keyboard layout option, and truthfully, you may have to adjust this depending on how your keyboard behaves with the new Raspberry Pi. I have some keyboards that work just fine out of the box, while I have others that do confuse characters, or perhaps will show me the pound sign instead of the dollar sign. So now we're done with internationalization. We're going to go down to advanced options. And I'm going to show you hostname, but we're not going to set this right now. By default, this comes set to Raspberry Pi. This is a setting we will be changing for every Pi we add to the cluster, but for now we're going to leave this as the default Raspberry Pi. Going back to advanced options, now we're going to set the memory split. Because these machines will only be command line only and only accessible via SSH, we won't be running any GUI. I will set this down to the minimum of 16 megabytes to make sure we have as much RAM available as possible for Einstein Home. Next, we'll go back to advanced options. Now, we want to make sure that SSH is enabled. Now it's asking us if we'd like to reboot, and we'll go ahead and say yes. After the machine comes back up, it'll now be useful to go ahead and configure our network settings, which we will need in order to be able to complete the apt-get update and upgrade that we'll need to make sure that our machine is up to date. For this, we're going to do sudo nano etc network interfaces. In this file, you will see that we have the ETH0, which is the Ethernet device which we'll be using. We also have WLAN 0 and WLAN 1. WLAN 0 by default is the Wi-Fi adapter on the board. We will go ahead and set this up in order to get on the network from the Pi so that we can do updates. The first thing we'll want to do is on WLAN 0, we're going to want to change manual to DHCP. telling the interface that it will get its settings via DHCP. Assuming that you're using a wireless network that has something like WPA2 personal encryption enabled, we need to add 2 lines. If you have something other than WPA2 personal, you'll have to Google to figure out what to put in, but this is probably the most common thing used. We do WPA-SSID, and in quotes we're going to place the name of our network. Next, we will do WPA-PSK, and in quotes we'll put the password. At this point, we can Control X to save, hit yes, and then hit enter. At this point, to bring the interface up, we can do a sudo if down WLAN 0. And now we can do a sudo if up WLAN 0 to have the interface restart. Now that we're connected to the wireless network, the next thing we need to do is update the Raspberry Pi. To do this, we will do sudo apt-get update. This will begin by pulling down the latest manifest of packages available from the repositories. Now that the update's complete, we're going to want to do a sudo apt-get upgrade. This will tell us what packages are available for our installation. You'll see that there are a few. One of the most important packages in this update, and the reason that we need to do it, is the OpenSSL package. There was a defect previously with OpenSSL and the CA certificates package available in Jessie that prevented the Einstein Home client from being able to communicate with the servers. To fix this, you used to have to hold back the original CA certificates package after downloading it via wget. At this point though, the bug has been fixed, and that OpenSSL package has made it into the stable repository. At this point, we have all the configuration and software that we will need in order to clone this image for every Pi in the cluster. There's more configuration and software to install specifically for what I call the Zero cluster, which serves as the DHCP server and NAT server for the cluster overall. Of course, given that every Pi 3 has a Wi-Fi adapter, you could technically skip that and just run them on Wi-Fi. You could in theory also, as I mentioned earlier, completely leave the switch and USB cable for the switch out of the picture if you didn't want to fool with it. I'm just simply choosing to have these be a wired connection to the Pi 3.0 node, simply for the fact that that's how I set up my Pi 2, and having the big switch on the bottom acting as a base for the cluster is helpful anyway, plus it keeps additional devices off my wireless network. At this point, we're ready to remove the card after the Raspberry Pi is shut down, and this will become the basis for our image for all other Raspberry Pis in the stack, both the master and all of the other nodes. I'm not going to go through specifically how to make a clone of this, but if you Google create image from SD card, you will find the appropriate instructions for your operating systems. If you're on Windows, there's a tool, Win32 Disk Imager, which is probably the tool you use to make your card, that will allow you to copy a card to an image. This is also why it's very important that we use the exact same SD card model and size for every single one of these devices. Because when it clones it, the image will come out the size of the card, and in my case that will be 16 gigabytes. So again, very important that you use the same SD card for all of your Pis in the cluster. Now that we have the Raspberry Pi configured on the network, it will have gotten an IP address and we can now SSH into it. So from my terminal, I'm going to SSH Pi, and I know 192.168.1.133 is the IP address on my network. You would get your IP address either locally from the Pi by doing an ifconfig command, or possibly by looking at your router and seeing what IP address has been assigned to it. Now, the first time you go to log into your Pi, you're going to receive a message like this telling you that the authenticity of the host has not been confirmed previously. Since this is the first time we're logging in, this is to be expected. I'm now logged into the Pi. Now we're going to start configuring the software for the first Pi. In this case, the first Pi will serve as the DHCP server, the NAT server, and the overall quote-unquote controller of the cluster, even though there's no orchestration or anything. But really the first thing we need to do is go into Raspbian config, go down to the advanced options, select hostname, and then give the machine a new hostname. In this case, I always name my machines rpi, and then the model number, in this case 3, and I give them a serial number starting with 0 for the first node in the cluster, in this case rpi 3-0. Now that we have Wi-Fi working, we're going to set up the Raspberry Pi 3-0 node, or the control node, with DHCP and NAT capabilities. And to do that, we're going to follow parts of a guide from Adafruit. I will post a link to this in the comments down below. This article tells you how to use a Raspberry Pi to create a wireless access point. Actually, in our case, we want to do the opposite. We want to create a wired access point that gives all the other machines on the network access to the wireless interface so that it can report results and get new work units. So the first thing we're going to need to do is install the DHCP server software. And by following this instruction, they tell us to install host APD and ISC DHCP server. Since we're not actually creating a wireless hotspot, we don't need host APD. We just need ISC DHCP server. Come back to the machine, sudo apt-get install isc-d, and I can probably tab. So it completed that much. Server. Now that the DHCP server installed, we're going to continue following along with the instructions from Adafruit. Sudo nano etc dhcp dhcpd.conf. And the instructions from Adafruit tell us to remove the comment tag in front of authoritative and to put comment tags in front of the option domain name line and the option name servers line. It then instructs us to go all the way to the bottom past all these examples. Here we're going to define our subnet, which will be the network that all the Raspberry Pi 3 nodes connect to. First, we're going to define a subnet. In this case, I'm using 192.168.2.0 because that's just what my preference is. There's no particular reason. You could use just about any subnet on the non-routable networks. We need a net mask, 255.255.255.0. Open curly braces. Next, we're going to give the DHCP server the range. So we're going to do range 192.168.2.100 to 192.168.2.200. And every line in here needs to be ended with a semicolon. Next, we're going to give it a broadcast address. So we'll do option broadcast -address space 192.168.2.255 semicolon. Next, we'll do the router address or the gateway. Option router 192.168.2.1, which is the Raspberry Pi 3.0, of course, semicolon. Max-lease-time will be 7,200 seconds, semicolon. We'll give it an optional domain name, and we'll call it rpi3. And then finally, we'll give it some name servers. And in this case, we want to use Google's, which are 8.8.8.8, comma, 8.8.4.4, semicolon. And then finally, close it with a curly brace. Now we'll Control X, yes to save the changes, and enter. Next, we need to adjust the server configuration. So we'll do sudo nano etc default isc dhcp server. In here, we're going to tell it which interface to use, which in our case will be ETH0. Next, we're going to modify the interfaces file. So etc network interfaces. Now we need to configure the interfaces file on our Pi 3-0 to be ready to serve as the DHCP server and NAT server for the rest of the Pi cluster. In this case, we need to make some changes to the ETH0 interface, starting by adding the line auto ETH0. We need to change from manual to static, as we will be assigning a static IP address. And to do that, we'll type address, and in my case, 192.168.2.1 with a net mask of 255.255.255.0. At this point, all the DHCPD components have been configured appropriately for the Raspberry Pi 3 cluster. It's a good idea to go ahead and reboot the machine to have the settings picked up by the ISC DHCP server. Now we will configure IP tables to provide network address translation services on our Pi 3-0. First, we start by editing etc syscontrol.conf. We want to look for the line that says net.ipv4. We're looking for IP forward. We're going to remove the comment mark and make sure that that is set to 1. Next, we need to run the following: sudo sh-c echo 1 /proc/sys net ipv4 IP_forward. Now it's been activated, but we're not finished just yet. Now we need to run the following 3 commands to configure IP tables correctly so that NAT will work. Starting with sudo iptables -t nat -A post routing space -o space wlan 0 space -j space capital mass q UERADE. Next, we need to do sudo iptables A forward -I wlan 0 -o ETH 0 space -m state -state related. And finally, sudo iptables -a forward space -I ETH 0 space -o wlan 0 space -j accept. First, we want to make sure that we have this correct by doing sudo iptables -t nat -S. Then we'll do sudo space iptables space -s. That looks good. Now, to make sure we don't lose these settings upon reboot, we need to do sudo sh space -c space quotes iptables -save space /etc /iptables.ipv4.nat. To make sure that this is used every time the interface comes up, we'll do sudo nano etc network interfaces. We're going to add a new line at the end of the iface ETH0 block. Post up iptables -restore etc iptables.ipv4.nat, which is the file we just created. This will ensure that every time that ETH0 successfully comes up, it'll run the iptables restore command to reset the routes and NAT that we need in order for this to work. At this point, if everything's been configured correctly, you should be able to do an ifconfig, and you will see that ETH0 has the static IP address that we've given it, in this case 192.168.2.1. The next thing we need to do is make sure that the DHCP server configuration is working correctly. At this point, you should have imaged one of the cards with the image we saved earlier, and you should have burned that to a card, inserted in the Pi, and powered it on, making sure that it's connected to the switch. If all went according to plan, that Pi should have automatically gotten an IP address from the host node, in this case rpi3-0. To see the address that's been assigned to the new Pi and to make sure it's working, we're going to do a cat command on var/lib/dhcpd.leases. Now, you may see multiple entries in here, but you can tell it's all the same machine by comparing the MAC address under hardware Ethernet. You can see in these couple of entries, it's the same address. And we're going to want to highlight this and copy it because we will need it for the next step. I've always found it handy to have the DHCP server assign fixed addresses to each node in the cluster so that I can remember which node is which by just remembering the IP address. For instance, the next node in the cluster will be rpi3-1, and so it will be helpful to always assign it the address 192.168.2.101. To do that, we're going to modify the DHCP server configuration file again. So we'll do sudo nano etc dhcp/dhcpd.conf, and we're going to go below where we set up the subnet earlier. And at this point, we will type in host and then the name of the machine, in this case rpi3-1, curly brace. We'll do hardware Ethernet, space. I'm going to do a Command V to paste the address from previous, and then a semicolon. And now we'll do fixed hyphen address space 192.168.2.101 semicolon. Now we'll close it with a curly brace. Eventually this file will have an entry in it for every node in the cluster for a total of 7 nodes. Now that we've made this change, let's cycle power on the second node in the cluster and bring it back online. At this point, if everything has been configured properly, we should be able to SSH into the new Pi at the address we've assigned it. In this case, Pi at 192.168.2.101. And it looks like we've successfully connected. The first thing we want to do now that this machine is on the network is to run Raspbian config so we can update the hostname. And in this case, we're going to name it rpi3-1 for node 1 in the cluster. And it's having us reboot. We're now ready to install the boinc-client. Now there is a package in apt-get called boinc, but this includes a lot of GUI tools that we don't need. So to do this, we'll do sudo apt-get install boinc-client. Now that that's installed, that has installed a tool called boinc-command, which is the primary tool that we will use for setting up and managing boinc going forward. Manually installing the boinc-client on every node in the cluster is a manual step that must be taken as you bring each node online. When you install the boinc-client, a unique identifier is generated, therefore it cannot be propagated through the base image. This unique identifier is important because if many machines have the same unique identifier, Einstein Home and other projects will reject work units returned by those machines. If you already have a boinc account, you can skip the next step. If you don't, you'll need to create one. And to do that, we're going to use the boinc-command command line tool that we just installed in the boinc-client. To start, you'll type boinc-cmd space -- create _ account space https://einstein@home.org, which is the name of the project that we're attaching to. Then you put in an email address, which in this case, I'll use my hamradio360.com address. Next, you'll enter a password. Then you'll enter a username for your account, which in this case, I'll just do jkhr360. After you've successfully done this, the system will return an account key for you. You'll want to make sure to go ahead and copy that key and save it off to the side. Now that you've created an account, there are a few settings at Einstein Home that we need to set to make sure we're getting the right types of work units for the Raspberry Pi. Visit in your web browser einstein@home.org, click Login. Here, we will enter the email address and password we created in the command line. Once we've logged in, click the View Account button. In the top nav, we need to go to Preferences. Under here, we need to click on Project. And for the purposes of the Raspberry Pi, we need to make sure that Beta Settings Run Test Applications is set to Yes. This is because the most optimized work units for the Raspberry Pi are still beta work units, and therefore we need to tell the account that it's okay that I get these. Scroll down to the bottom. Once at the bottom, click Save Changes. Because we're building a dedicated cluster for Einstein Home, we need to tell the boinc-client that it's welcome to use all the resources available to it on each node. To do this, we click on Computing, and then we click down here on Maximum. This will ensure that it's able to use as much resources as possible from each node. Then click Save Changes. At this point, we've done everything we need to do in the Einstein Home website. Eventually, you'll be able to come back here and track the progress of each node in your cluster to see how it's doing overall against the project. Just like installing the boinc software on each node in the cluster, the following step will need to happen on each node of the cluster as well. Now that we have the centralized boinc settings configured to give us the most optimal experience for working against the Einstein Home project, we now need to attach each Pi to that project. To do that, we're going to use boinc-command again. This time we'll use project_attach, the URL of the project, And then finally, we have to use the account key from above. It's helpful to copy this whole command string so that we can easily paste it into each node going forward. Now that we've done it, there's no command line return, but if we run the command top, we can see that there are 4 boinc instances running right now. And what we're waiting for is to wait for these boinc instances to turn over into Einstein Home instances. When the boinc instances initially start, they run a profile to get an idea of how fast the CPU is. Then, each one starts downloading work units. The boinc commands are replaced with Einstein binary to demonstrate that Einstein work units are actually being worked by the CPU. In the end, you will see 4 of these processes running. Now we see there are 4 instances of Einstein binary running, all effectively using approximately 100% of the CPU. To configure the remaining nodes in the cluster, for each one, burn the base image and boot the new Pi using that image. Look at the leases file on the 0 node to find the IP address and MAC address of the new Pi node. Add a host entry in the dhcpd.conf file. Reboot the new Pi, log in and change the hostname using the entry you added to the dhcp.conf file. Install the boinc-client using apt-get, and finally connect to Einstein Home project for each of the new nodes. If you've done this, you will have fully configured your new Raspberry Pi 3 cluster.